This tutorial is going to help you answer a question that asks you to explain the effects of climate relief and drainage on the formation of, and in this case, we're going to look at the Podsol. This question you're likely to have to answer will look something like this, which you can also find a model answer for if you go to the main revision site, Biosphere, and look at the model answer section. Now, the first thing I would encourage you to do when answering this question is, looking at the wrong one there, is to actually revise the video or the answer for drawing and annotating a diagram to show the characteristics of a Podsol. Because in that, you've actually got all of the descriptive statements, which will help you answer a question that asks you to draw and annotate a diagram, but also forms the foundation for the answer I'm about to talk you through. Okay. I often find the Podsol the easiest one to write about. There's quite a lot going on in this soil, so there's loads of points you can make that explain this soil. This soil is a little bit between, like the soil that's halfway between a brown earth and a clay. So it's not as rich and nutrient rich and deep as a brown earth, nor is it as waterlogged though as a clay. Okay, so let's think about each of these descriptive labels and then turn the descriptive label into a point of explanation to get a mark for explanation. And every 2 times you make a descriptive statement, you'd be picking up an additional mark. So you could say that the soil is formed from coniferous forests, which grow in colder areas of the world, like the boreal forests of northern Russia. And that the pine needles, when the pine needles fall off the trees, they slowly decay to form the thin black humus. If you want a point of explanation there, you can say they slowly decay because the climates are often very cold. Another point to do with climate is you can say that because the climate is very wet, it promotes a lot of leaching, which means that the nutrients released from the decaying pine needles will get washed deeper down into the soil. You can say that the soil is very dark and coloured in the O horizon, and that's because of the decaying pine needles. You can say that the top end of the A layer is often quite dark because of the black humus above in the O horizon, which is washed down or leached downwards to create a much darker top part of the A horizon. As we move further down the A horizon, it becomes an ash grey colour, and the reason it's ash grey is because a lot of the nutrients are washed out of it downwards because of the high level of leaching in the soil. And leaching is the most common process in the soil with very little evaporation upwards. That's where stuff is drawn back up, and that's because it's a cold climate, and therefore there's very little evaporation upwards, and because of the heavy rainfall, most material is washed downwards. You can say that there are shallow roots because most of the minerals are only present in the very top of the soil, and there's very little mineral content further down, and therefore the roots don't bother going much deeper into the soil. The lack of roots going deeper into the soil also means that there's very little in terms of capillary action, with very few minerals being drawn up by root systems. An iron pan develops between the A and B horizon. You explain that this is due to iron compounds being washed or leached out of the A horizon and then gradually building up over time to form this iron pan. The reddish-brown colour in the B horizon is created by iron compounds gradually oxidizing in the soil and turning red. That process is basically where the iron compounds gradually rust because they mix with water. The layers are very distinct. You can see the A and the B very clearly in this soil, and the C, and that is because there is a lack of mixing in this soil because of a lack of soil biota. And there's a lack of soil biota, or there are some, but there's not very much because of the cold climate and because of the high levels of rainfall, which means it's difficult for organic life to live in this soil. The soil is relatively nutrient poor because it forms on a parent material that is often weathered rock made from deposited glacial rocks, which are quite nutrient poor. However, it is reasonably well drained because these aren't impermeable rocks, so water that does leach downwards can drain through the sea horizon. So it's not a waterlogged soil like the clay is, for example. Okay. It's got a very sandy texture, the A horizon. That's largely because all of the very much smaller clay particles, which you would also find in soils, are so small they actually get washed downwards, and therefore the A horizon ends up being quite sandy in texture because it's lacking much in the way of clay or silt, which are smaller particles. That's the point when you try to explain why the A horizon's quite a sandy texture. Okay, and finally, if you want to say that the moor humus found in the O horizon is acidic with a high pH, you would then want to explain this comes from the decaying pine needles, which are also very acidic from the coniferous trees. Okay, so what you'll see, I've gone through a lot of this diagram and given a descriptive point and then sought to offer an explanation. And I suggest you rewind it and play it again and write down each point of description and then try to explain it in your own words. Possibly look at the model answers either on the revision site or in your own class notes. Remember, you are looking to be able to probably write about 8 of these points, and I've described far more than 8, because this question could be worth a maximum of 10, although more than likely it's going to be 8 or 9 marks.